Okay, well, it's 14:00 Central European Time. Welcome everyone to this workshop from IEA Energy Storage Task 39. And I'm going to start by presenting the program. I will be making this introduction for the next 5 minutes. And the title of our workshop today is Are Large Thermal Energy Storages a Key Element of the Future Energy System? So the program today, it's quite packed. After this introduction, some experts will make presentations and there will be room for questions. The priority will be given for the panel members to ask questions, but you can also put your questions in the Q&A box of this webinar on Teams. So please use the Q&A for asking your questions to the presenters or the panel members. Then we will have presentations from energy agencies from Sweden and the Netherlands. And then we have a small break. Then after the break, policy stakeholders will be presenting 2 short presentations of 5 minutes, both from Austria and the European Commission. And then from 3:20 to 3:45, we will have a 25 minutes panel discussion. And to finish, a Q&A session with the audience, where we will select your questions and ask them to the panel members. So very briefly, an introduction on what IEA ES Task 39 is. It's an international TCP on large thermal energy storage. It groups 11 countries from 36 institutions, and here you can see some of the logos. We are investigating 4 main large thermal energy technologies: tank thermal energy storages, TTES, pit thermal energy storages, PTES, borehole thermal energy storages, BTES, and then aquifer thermal energy storages, ATES. And then IEA Task 39 has 4 subtasks. Subtask A on application scenarios, subtask B on components and materials, subtask C for round-robin simulation, and then subtask D for dissemination and making a knowledge base. And the goal of Task 39 is to give tools, references, and methodologies to guide stakeholders of LTIS projects. And those stakeholders are our main targets for the stakeholders are project developers and project owners, researchers and engineers, and then policymakers, as well as the general public. And that's the whole point of this workshop, is to involve policymakers. If you want to get more information about Task 39, please contact the task manager, which is Wim, your national TCP delegate, or me, and you can follow the website as with the link below. My name is Jeffrey. I'm a calculations engineer at Plan Energy. I'm a part of the Danish consortium from IEA ES Task 39. And our Danish consortium is supported by EUDP, which is the funding agency from the Danish Energy Agency. And I will be the moderator of today's talk. And in Task 39, I'm the subtask leader for subtask D, which is focused on disseminations. Now, the aim of the workshop today is to answer one question: are LTIS, large thermal energy storages, a key element of the future of energy system? Present the challenges, highlight the opportunities, and show best practices from the EU regarding LTIS. And then engage, and that's the most important part, engage discussion between experts of LTIS, energy agencies, and policymakers to see how and what to do to make LTIS reach their full potential, and what are the next steps to get to that goal. So without further ado, we will start with the, let's say, first real part of this workshop, which are the experts' presentation. And I will hand it over to Wim, who is our first presenter today from Austria, AE Intec. Wim, you can now share your screen.
Thanks, Geoffrey, for this introduction. The question is almost answered, at least for my part, from the Austrian part, because we are working on large thermal energy storage since more than 5 years now, and we think they are a key element in at least district heating systems. Why is
Wim, you just got muted.
Okay, yeah, thank you.
Good.
LTES can be seen as a sort of pivotal element in the district heating systems because they enable more flexibility in the network. They can make possible that different heat sources can be connected to the district heating system. And especially larger thermal energy storage systems can enable a seasonal storage of heat and therefore assist solar thermal or deep geothermal heat as a primary source for district heating. We investigated a large part of the component development and material development for pit thermal energy storages in the Austrian flagship project GigaTES, and you can find the final report of this project at the website mentioned here below. If we calculate what the district heating consumption is in nowadays, so in 2018 we have numbers on the final energy consumption for district heating, then it's in Europe 446 terawatt hours. And then if we want to calculate what the growth and the necessity of pit thermal energy storages is for district heating, then we assume that 40% of the large thermal energy storages needed of the 4 technologies is pit thermal energy storage, and that 30% of the annual heat sales has to be stored in order to enable the use of renewable heat in the winter. At present, the pit thermal energy storage capacity then would be something like 54,000 gigawatt hours. And with a 4-fold growth that is also expected on a European basis for district heating until 2050, we need 220,000 gigawatt hours of storage capacity. If we then see at this graph, say the x-axis the year until 2050, and on the y-axis a logarithmic scale of the capacity needed for pit thermal energy storage in Europe. We start now in 2023 with a reference project for our treasure project of about 13 gigawatt hours. At the end of the project, we would like to have installed 100 gigawatt hours, and with the satellite initiatives, we will be about 420 gigawatt hours, but we need to go up to the 220,000 gigawatt hours, which is several thousands of very large pit thermal energy storage in Europe. So in order to achieve this, we have a vast work ahead. And in order to accelerate this, several measures are needed to have the uptake of pit thermal energy in such a way that we can respond to the demand that there will be in 2050. One of them is raising awareness, so information about technologies and processes and permits and procedures to bring this information actively to the participants, to the participating stakeholders in the process, like Geoffrey mentioned. So R&D, but also decision makers, policy makers, and owners and developers of these projects. Second main point is to reduce the uncertainties in the process. So this can be done by getting awareness on the permitting procedures, on the permitting levels, and also get uniformity into the procedures. Also working on standardization is key for that, defining key performance indicators and measures to measure these indicators. Another important point is to shorten the realization time. making sure that the time between the first plan and the realization, the operation of the pit thermal storage is being shortened by uniform communication and protocoling procedures, and by exchanging experience. And also decreasing cost is very important. Make sure that components and processes are being developed and improved in order to cut down the cost, and also to exchange experiences in order to make it, say, a main market for different players. So that's why we started the Treasure project. It's an European-funded project. It will start January next. And the idea of Treasure is to demonstrate large pit thermal energy storages and improve their components and processes and procedures in order to have an accelerated realization of 100% sustainable district heating networks in Europe. That's a mouthful. And we will do this like shown here in the diamond by the several measures that already have been indicated in the 2 slides before. To strengthen the expert base, making sure that more engineers and experts know about the technology. To improve the energy efficiency of the complete system, to reduce its cost, to shorten the realization time, to lower the financial risk, and to have an experience-based knowledge on which the new generation of pit thermal energy storage can grow. A very short project outline of the project. The idea is that we have 7 demonstrators in 5 European countries. They are indicated here on this map. We have 2 demonstrators in Poland. We have 2 demonstrators in Germany. And we have 1 demonstrator in France, 1 in Austria, and 1 in Serbia. And the blue demonstrator here in Denmark, Høje Taastrup, will serve as a monitoring demonstrator because this project already has been realized, and the monitoring data will flow directly into the experience of the new to be developed projects. The area or the size of the squares indicate the planned size of the storages. And the 4 dashes below indicate the state of development of the different storages. So yellow indicates still in planning. So the first 3 years in planning and the 4th year for LOBAS for monitoring. And for Hechingen, for instance, 1 year of planning in 2024 and 3 years of monitoring until 2027. So then we have a broad collection of different demonstrators in different stages of development. And the idea is that through the collaboration within the project and through collaboration also with 15 satellite initiatives, we thrive at getting all these methods and procedures and components more into the market and accelerate therefore the uptake of pit thermal energy storage. The project has 25 partners, and we will start in 24. It has a duration of 4 years. So I guess that with this project, we can partly answer the question whether large thermal energy storage are key for the future energy system. Thank you for your attendance.
All right, thank you, Wim. Apparently, Geoffrey has a small problem with his computer, but I'll try to take over. So maybe very quickly, if someone has one question for Wim. That's okay. I mean, you can also write your questions in the Q&A, so we can also take them later. Thank you, Wim. So we'll move on to the next presenter, which is Pierre from NewHeat. Pierre, the floor is yours.
Thank you, Johannes. So I'm Pierre Delmas. I am one co-founder of the company NewHeat, and I'm the technical director. Can you see? Hello, everyone. Can you see my screen?
Yes, it looks fine.
Great. So I'm Pierre Delmas from NewHeat. NewHeat is part of the Task 39 work, we are leading the subtask A on application scenario. And we are part of the Treasure project also that Wim just presented before. So through these 3 slides, I will present what LTES solution represent for project developer like NewIt. So first, to present NewIt, NewIt is a young renewable heat supplier for large heat consumers, large consumer being process industry and district heating networks. We supply heat during 15 to 25 years, leading and financing all the different steps of the project, from the design of the solution, then managing project development, integrating the securing of the land needed for the project, securing the permitting, meaning urbanistic compliance, risk assessment, performing risk assessment to get the permits, the full permitting of the project. Then eventually secure public support if available, and secure typical or specific technical constraints related to the project, like specific ground conditions, or if we need to cross a road with our pipes to deliver the heat. So this position and this work of developing projects allow us to have a very wide vision on the challenges that this LTES solution represents. And then we coordinate the building of the renewable heat plant, and we operate it and control it during the heat purchase agreement duration. As we finance all the cost of the project, we are the owner of the assets, of the production assets, and we are the owner during the whole period of the project. The heat production assets developed by NewIt are always based on storages. This brick offering the flexibility needed to handle the production and demand dynamic constraints. Renewable heat producers are very often dynamic, and competitive heat is available not necessarily in the same time as the demand. So these tools are very key for us, making the storage always a cornerstone of our systems. And then NewIt and its clients apply a solution assessment following this merit order presented here, from heat recovery, going through solar thermal, heat pump, through renewable electricity when available, and then biomass solution, depending on local resources and constraints for each specific project. So as you maybe understood, the NewIt do not own any technology. We act as a system integrator, selecting the right solution for each situation, each heat consumer. So to be a good system integrator, we developed 3 main know-how. The first one is advanced modeling skills, meaning that we use tools that represent in a dynamic way and through a thermo-hydraulic representation the behavior of the system. We design the systems including the different constraints with some targets such as heat price target, price stability expectation from the client. And then we design specific and optimized control strategy to take advantage of the possible evolution from the heat demand side, or from the price of energy sources during the time of the 25 years of the project. So now let's focus on the key advantages of large thermal energy storage for us as a system integrator and a system operator. When we look at large thermal energy storage, first we see low-tech infrastructure, meaning that the working principle is always quite simple. There is no need for rare and critical material in the construction and realization of the project. Generally speaking, these storage solutions are competitive, especially compared with other form of energy storage we can have as an option. And when it comes to use heat as a final form of energy, then the more competitive way to store it is through these large thermal energy storage. And these assets have a quite long lifetime, especially and for Nuit, when you consider long-term commitment in the contracts between the supplier, such as Nuit, and the client, this long lifetime can become an advantage, especially for the competitivity of the solution. When we select LTES option in our project, when this solution is relevant for a specific heat consumer situation, we can benefit from different advantages offered by this solution. The first one, so the LTES offer flexibility. It's a flexibility tool that allows to decouple the production strategy from the demand constraints, allowing energy arbitrage that can evolve based on evolving constraints and opportunities, which could occur from the production and recovery side during the operation period of the project. For example, whenever cheap heat recovery or cheap electricity happens, the system can take advantage of it and then discharge it when the demand is arriving. This decoupling between production and demand allow to maintain the different producer in optimal working condition, allowing a better performance over the time, because renewable energy sources often are not that available or flexible, and this flexibility tool offer a possibility to remain in very good and performant operating condition for these producers. Then this flexibility tool allows to limit the need for reactive and dynamic producer, such as gas, very often that is used to adapt or always adjust the production to the demand, and then allowing to reach higher renewable shares in the system energy mix. And also those investment can also save some production investment, replacing for small and dynamic producer that could be needed to complete the need for heat during the whole year. And to finish, these tools also offer a much more flexible operation and maintenance situation for district heating network and production operators. As for example, in case of an incident on a producer, then the storage can take the relay and deliver the heat while the problem is solved from the production side. So these are the different advantages that we identified from such a solution. And well, if you have some question, or maybe we'll have the opportunity to discuss more about that in a further stage. Thank you very much.
Thank you, Pierre. I am back.
You're back.
Sorry for my problematic connection. We have 1 minute for one question. If someone, preferably from the panel, has a question, then you can ask it now.
I would have one question. I'm Paul Amsak from Netherlands. I will be on the panel later. How many of these projects have you already realized in France or anywhere?
So I was short on the description, but we started with solar thermal technologies. So in each solar thermal plant, we have tank thermal energy storage. We started the company in December 2015, so it's a young company. We have 5 projects in operation, 5 T-tests, and we are now developing LTES. But as Wim briefly presented, it takes some time to go through the whole process, and so we have something like around 10 projects at different level of maturity, but still moving forward. I don't know if it answers your question.
Yeah, very much. Thank you.
Thank you very much. We'll move on to the next presenter, Jens Kühne from AGFW. You can share your screen.
All right. Yeah, thanks, Jeffrey. And thank you for having me today and for the opportunity to explain the position of the German District Heating Association on large thermal storages. Let me briefly introduce myself. I'm Jens Kühne. I'm the head of the Department of Generation, Sector Coupling and Storages at the German District Heating Association, AGFW. We, as an association, represent the interests of nearly 700 member companies active in the field of district heating in Germany and in Europe. Yeah, I've seen this graphic in Wim's presentation already, but nevertheless, I have something to say to this graphic also. So let's dive into the topic of the LTs. In Germany, district heating is usually by approximately 80% produced by fossil CHP plants. But in the near future, we will have a vast variety of different heat generation techniques and sources ranging from, as we can see here, large heat pumps over geothermal, biomass, surplus heat, direct electric power to heat technologies, solar thermal, and then also waste energy. Along with this huge transformation from fossil CHP to these renewable sources, we also see developments in the role of thermal storages. By now, the heat storages serve mainly for balancing short-term differences in the heat demand and the heat generation in order to maximize the revenues of the electricity sales on the market. In the future, with more and more renewables and excess heat, we can see a higher demand of long-term storage for balancing the mid and long-term availabilities of the sources in order to ensure and optimize the year-round heat generation. For example, solar energy or the lake and river heat generation by large heat pumps, as we definitely see in Germany evolving right now. At this point, I just want to say that large is a relative definition. So as we could see in the introduction of Geoffrey, for a small district heating system, a tank storage can also be a large energy storage. So we often see a large the LTs as pit storages, but we also have different other technologies that can act as a large thermal energy storage. But to add on this, in Germany we see district heating most often situated in large cities, which is a fact that distinguishes Germany from Denmark. In general. So in this context, we see district heating systems in highly dense areas with high specific heat demands and unfortunately also high property prices. So of course, there may be the option to build up transport pipes to large energy storages in the outer range of the cities where property is affordable. But the piping alone would mean very high investment costs connected with difficult thermohydraulics without any feasibly connectable customers on this way. But we also see promising concepts and ideas for LTs in Germany. We not only do we see the classic pit thermal storages as in Denmark, rather in small and new district heating systems in rural areas. But we also see concepts of large aquifer storages, for example, in Berlin with more than 20 gigawatt hours or Hamburg with 5 gigawatt hours. There are also existing borehole storages that can be a blueprint for future concepts, for example, under solar thermal collectors in combination with a large heat pump. And so we can have a double usage of this area in order to minimize the costs. But when we talk about the aquifer storages, we can see advantages for the realization in Germany in contrast to the pit storages, which is a low demand of area and hence a low demand of new property, which has to be bought or just But we also see with these aquifer storages high investment costs and the need for specific geological circumstances. For the borehole storage, I already said that we have a double usage. But this is with this I already come to the end of my brief position on LTs in Germany. But let me just add another last statement. So in Germany, we are at the beginning of the transformation process of the large district heating systems we have in Germany. And I hope that the innovative concepts for large thermal energy storage within the context of this whole transformation process are yet to come. So, and now I'm happy to answer all the questions that may be risen.
Thank you very much. And well, I'm happy to hear you eager for new technologies to come, because that's exactly the topic of the follow-up task of task 39. How to accelerate the intake, but also intake of LTES, but also to have a look at improved designs and technologies. Is there a question for Jens in the panel member?
Yes, I would have a question, short. Hi, Jens, regarding the different possibilities for large thermal energy storages in Germany. Has there already been a study into what the possibilities are geographically for the different technologies? If you look in to Germany, to the different, say, geological constraints.
Well, the geological constraints, you mean for storages, or for aquifer storages, or?
Yes, indeed, yeah.
Yeah, so actually Germany starts right now with geological surveys or analysis in order to have information and data for geothermal usability in every kind. So also geothermal heat usage, and not only as a storage, but also to have a heat generation. But there we only we have started. But in some areas there are more detailed information available. In some others they are a little behind. But I think it starts right now, and we'll hope to get them further information in the next year.
Oh, that's great. Thanks.
But this is more focused on geothermal heat usage than on storages. But maybe it comes together with the information.
I guess yes. If you have the information of the underground, then it also can be applied to how do you say, scenarios for geothermal and for aquifer.
Yeah, and that's what we also that's the project that I just introduced, the large aquifer storage of 20 gigawatt hours in Berlin, which is, I think, a very good project to see what's somehow possible also in a large metropolitan area.
Thank you very much. And if I may add, in terms of inspiration for underground geological study and mapping, we will relay the information with the deliverables from Task 39 by giving some references to other projects, but the project Heat Store has focused largely on this to do screening in the Netherlands, in Switzerland, and in Denmark as well. So the methodology is already out there, and you can probably get inspiration to see how this kind of screening can be used. And I know for a fact that Sweden is also doing screening of potential of underground thermal energy storage with regards to geological conditions. And before I give the word to our last expert of the day, please, for the audience, make good use of the Q&A box at the top of the webinar to ask your questions. There will be a Q&A session at the end, and you can already put your questions in there, and we will take them there. Right now, I'm prioritizing the panel questions in order to facilitate the discussion later on, but please feel free to put your questions in there. And with this, I will give the word to Per Alex Sørensen from Denmark to make the last presentation. And just unmute yourself, Per Alex.
Can you hear me now?
Yes.
Okay. And then I have to. So,
perfect.
Yeah. Yeah, my name is Per Alex Sørensen. I'm team leader in the energy storage team in Plan Energy in Denmark. Plan Energy is a private consultancy company. So we are not building things, we are consultants. We have been working with pit thermal energy storages in the last more than 30 years. So I will give you a short introduction of this work and the status in Denmark now. So it started with very small storage in DTU, Danish Technical University, in the early 80s. And that was actually the beginning of the pit storage development in Denmark. And in my backyard in Ottergård, there's another storage, 1,500 cubic meters. It's the first pilot, you could say, outside DTU. And then the second pilot is in Marstal in the island of Ærø, and it's 10,000 cubic meters. It's from 2003. And the first full-scale storage was also in Marstal. It's from 2012. 75,000 cubic meters, and it has nearly 7,000 megawatt hours when it's full. Then Dronninglund came in 2014, and Gramvoies and Toftlund in 15 and 17. And then there's one in Tibet that's actually not part of Denmark, sorry. But those first storages, they were all made to store heat from solar thermal plants. The idea was to have a very high solar fraction with solar thermal plants to produce renewable energy for district heating. The last one is Høje Taastrup. It's finalized last year, and it's in operation now. So I'll just show you two examples. This is the example with solar thermal. It's the Dronninglund from, it was built in 13 to 14. It's 60,000 cubic meters, and there's more than 37,000 square meters solar collectors. And it's connected to an absorption heat pump. You can see the storage in the background and the solar thermal in the front. And of course, as Jens said, this is difficult to find place, at least for the solar thermal part in the cities. It was an old gravel pit. Up left, you can see the beginning. And the principle in Peters is that when you excavate, you use the excavated soil to the banks so that you have a soil balance. And in the middle, you can see the in and outlet. And then after that, there will be a membrane. It's a polymer membrane. And then water can be filled in, and the floating lid will then come on the top. So that's the simple construction. And in this case, it was in sand, so it was very simple. But that was the solar thermal examples. But the last example, that's another kind. It's outside Copenhagen, and you can see there's a motorway on one side, and on the other side, there's actually a water pipe, drinking water pipe. So it's a limited area. But it's near transmission pipes in Copenhagen, so it's possible also to find this kind of areas near the big cities, at least in Denmark. It is providing flexibility to the district heating system in Copenhagen. So it's mainly there are 7 combined heat and power plants. 3 of those are waste incineration plants, and 4 are biomass plants. And they can earn more money if they are allowed to produce more electricity with high prices, and in those periods, hot water is supplied from the straws. So that's one way of gaining money. Another way is more efficient use of the waste incineration plant in the summer period, and the third possibility is to shave peaks from the gas boilers because there's 30 megawatt in an outlet, and that's you could say only it's not the limit. You can have 100 or 200 megawatt if you want. Because the temperatures are 90 degrees all year round, opposite to the solar thermal storages, we had to use a new membrane, a polymer membrane from polypropylene. And also we had to be very careful with the insulation material in the lid. We use a foam material, and it has to be tested to see if it can stand the temperatures. But that's the short introduction. You can see here how it's not charged in summer and discharged in winter. It's charged and discharged all the time. The last step is a project called Integrate 2. And all those projects, they have been supported by the Danish program EUDP, which has been, I think, working for 20 years at least, supporting different projects. And among those, the Peters projects. And in the Integrate 2 project, we are investigating the next generation, you could say, or further development of the Peters. And it's with 2 cases. One is in Copenhagen still, and you can maybe see to the left, there's Roskilde, and there's 30 kilometers transmission pipe from Roskilde to the center of Copenhagen, and another 30 kilometers to the south. And that's actually in Høje Taastrup, near this transmission pipe, we have the first storage. There's another possibility near Roskilde, and it's calculated in this project. And another case is showing Hirtshals, where we use excess heat from a harbor to see if that's feasible. And in that project, we have a lot of testing going on, and it's together with the University in Linz in Austria. So we are testing membranes to see if we can get even higher lifetime than we have with the PP now. We are also testing them under real conditions, it means that we will put parts of membranes into the storage in Copenhagen, in Høje Taastrup. We are testing the foams for the insulation, and just now we are discussing with the supplier of the foams if they can change the formula for preventing degradation of the foam. We have tested material for weight pipes on the lids, and then if we can avoid corrosion in and outlet, it would be very nice. So we are also testing fiberglass as a possibility for in and outlet. And from all that, we come up with design solutions. That will be, you could say, it's not radically changed from the last storage in Høje Taastrup, but it will be a bit more further developed. So thank you for the attention.
Thank you, Per Alex. In order to make sure that we have a proper break in 10 minutes, I'm going to give the word already to Emina, and maybe we'll be able to add some questions in the Q&A session at the end. So Emina, the floor is yours. Thank you for being present.
Thank you. And I try to share my presentation.
Yes.
Yes. Thank you very much for the opportunity to just shortly present possibility for funding at Swedish Energy Agency, and I'm Emina Pasic, ex-co-delegate for IEA Energy Storage TCP program. Maybe I can turn to, do you see my slides?
Yes, it's perfect, and now it's in full screen.
Yes, and I just shortly present Swedish Energy Agency via National Authority for Energy Policy Issues and even national funding agencies. And our mission is to leading society transition to sustainable energy system. And from the 1st of January, we are sorted under Ministry of Climate and Enterprises, and our general director is appointed by government, approximately 400 employees, and it's 62% women and 90% academics. Just shortly introduction about our heating and cooling strategy, which we actually started in 2017, that we had in that time the national programs related to the respective technologies, heat pumps technologies, district heating technologies, and others, solar heating and cooling technologies. And in 2017, we started this initiate work on strategy for heating and cooling, and to identify how to actually design the strategy for heating and cooling for the tomorrow. And on the left side, you see that in that time when we started with these incremental programs, and just turn to the identified possibilities and turn to the right side, that we see the future, how we would like to design future activities and, of course, funding programs. That is collaboration between actors and industry in focus, user-oriented development, and system solutions, flexible and robust, together with the circular economy services and digitalization as instruments. And now it takes time to turn to the next slide. You'll see. Sorry for this, but
no worries. Maybe try with your keyboard.
I tried.
The arrow.
But it's like, yes, and just a few words about the vision and how we identify the objectives for the 2030. That is like for the main objectives, energy resources, with the focus for heating and cooling consists of recycled and renewable energy. Excess heat from different sectors is used as and benefits society. The second one is integration in the energy system. Interaction between heat and cool and the other energy carriers contribute to resource and cost-efficient energy system. And
Irina, we cannot see your presentation now.
Okay, sorry.
Thank you.
Just start again. Something with the Teams today. Maybe I continue in this.
Yeah, I think it's fine.
Maybe it's okay. And as I mentioned, it's like a four main objectives for 2030. Energy resources, interaction between energies in the energy system, and resource effective use, and innovation for the job and climate. I'm not going to read all these parts, but if we looking to the next slides, how we today and in this year, 2023, moving forward these activities and try to take a next step and design the program for upcoming period. And we prepared the strategic movements with the new thematical area, circularity of materials as a part of resource efficiency, nuclear heat and surplus heat from the nuclear power, and security of supply. More clear included, and it includes focus on flexibility, excess heat, business models, sector connection about all the electricity grid. And at the same time, from the previous strategy, stay on the course for comprehensive approach for heating and cooling system solutions, demarcations against the energy authorities' other programs, and thermal energy storage, and reduced focus on industry-specific incremental development, niche projects by individual actors, small-scale solutions with limited opportunity to contribute to the transition of the energy system. And if we're looking for Swedish Energy Agency research and innovation funding portfolio, we have approximately 1.6 million euro annual budget for different thematical issue, and Thermo is National Program for Heating and Cooling, which is dedicated, also is a part of this national annual budget. And emphasize a needs motivate research with TRI 4 to 7. And in our national, from this strategy work, this operational design of the program is focused on the heating and cooling, integrated all the heating and cooling technologies. And this program is running since 2018 and in different periods of 4 years. And after each 4 years, we evaluated this program and to add more national budget depending on the results of evaluation. And this year, we're preparing also new decision for the upcoming 4 years with approximately 60 million euro in budget for upcoming 4 years.
Emina, can can you please finish up within the next minute such that we can give
yes,
the word?
Yes, of course. And this
Thank
is
you.
like all four parts of this program, which is integrated and focused, including even large thermal energy storage, heat pumps technologies, district heatings, balanced thermal grids, and all heating and cooling technologies. And just to mention also the last slides is about the information for our national program, but even I would like to stress two European partnership, which we allocated a national budget for participation in European Partnership, Clean Energy Transition Partnership, special TRI 4, efficient zero emission heating and cooling solutions, and DOT partnership for transition pathway positive energy districts, which is also connected to the large thermal energy storage solutions, and we allocate national budget for these two collaborative programs, European programs, which means that we can also have the national project, which is part of this two European partnerships project at the same time would be part of IEA Annex 39 and the other annex in this collaboration. I think this is my last slide. Yes. And
Thank
if
you.
you have any questions, I'm here maybe a few minutes, and otherwise you can send me email and I'll try to answer. Thank you.
Thank you, Emina, and we will share your slides on the IEA Task 39 website. Thank you. So now we'll give the word to Robin from the Netherlands Enterprise Agency, RVO. And you have 5 minutes. And you are muted for now.
Oh, yes.
Thank you.
Okay, I think it works now. Do you see my screen?
Yes, it's perfect. Thank you.
Great. Okay. Hi, everyone. My name is Robin Hofmans, and my colleague Paul Ramzak, who will be joining the panel discussion later on, and I work for the Netherlands Enterprise Agency, which is RVO in Dutch. And RVO helps entrepreneurs and organizations to invest, develop, and expand their businesses and projects, both in the Netherlands and abroad. We are a governmental agency, which is part of the Dutch Ministry of Economic Affairs and Climate Policy. Paul and I work at the Department of Energy Innovation and in the Heat and Subsurface team, where we handle innovative subsidy projects and give advice regarding sustainable heat transition in the Netherlands. In the picture on the left, on the slide, you can see that the drilling of the first high temperature aquifer thermal energy storage, so ETS, being drilled in the Netherlands. This project is located in the province of North Holland, and it stores heat at 85 degrees in the subsurface at a depth of approximately 360 degrees. And it's part of the heat store project. And we are happy to say that it has already had almost 3 full cycles of charging and discharging. And this project is providing us with a lot of knowledge and experience around this technology. So this doesn't work. Okay. Should go to the next slide now. Yes. Okay. So in the Netherlands, we the climate agreement was presented in 2019, and this agreement contains many sub-agreements to combat greenhouse gas emissions. And one of these agreements is to close the gas tap and switch to green energies such as solar and wind. And I probably don't have to tell you, but unlike gas, the supply of solar and wind is not always the same. So there's a difference between day and night, but also between weeks and even seasons. And in addition, the energy demand is also not constant. So if we zoom into the final energy demand, we see that approximately 50% of the Dutch demand is needed for heating. But if you look at the picture on the left, you can also see that for many countries in Europe, the final energy demand is mostly made up of heating. So to both match supply and demand, storage, and in this case, for example, heat storage is crucial for our energy system. So to answer the workshop question, storage is actually key in the Netherlands, and I think also in many European countries. The Ministry of Economic Affairs and Climate Policy emphasizes the need for storage and for a sustainable and flexible future energy system. And that's why they offered the energy storage roadmap to the Dutch Parliament. Or also routekaart energieopslag in Dutch. So if you want to look for it, look for the Dutch name. There is an executive summary in English. This roadmap is published in June this year. The roadmap divides storage in 3 pillars, namely heat, electricity, and molecules. And by molecules, we mean mostly hydrogen or hydrogen carriers. For each pillar, different points of actions were set up that need to be rolled out in the upcoming years. And the main message is to choose the type of storage dependent on the situation and choose what is logical for the location or situation. So for example, if you look to the right, the electrical storage is chosen for storage of energy, for example, for seconds to hours. And for example, heat storage is chosen for large capacity and over longer periods of time. In the Netherlands, we also intend to build heat networks for a future sustainable heat and cold supply to our built environment. And the roadmap states that all district heating networks should contain an LTS, which is quite a big undertaking if we need to do this in the upcoming years. But it's still very good doable. So if you see on this slide, we have quite some experience regarding LTS in the Netherlands, and this is basically because we are privileged to have a good subsurface for aquifer thermal energy storage. And the experience started in the 90s, where we started with low temperature ATAS. You can see in the left picture that there are many LT ATAS systems throughout the whole of the Netherlands. We also built a regulatory framework for these type of techniques, which we use as a base case for other, for higher temperature or mid-temperature ATAS and even mine thermal energy storage. If I would have put up the picture of the ground source heat pumps, then the whole Netherlands would color. We have approximately 50,000, but these are the smaller and out of scope of this workshop. And we have approximately 6 mid-temperature ATAS systems if you look to the right, and 1 high-temperature ATAS system, which I already showed in the first slide. And if you look in the south of the Netherlands, near Heerlen, you have the mine thermal energy storage, which stores heat in the mining galleries of a former coal mine. So that's basically what I wanted to tell you, because I only have 5 minutes. But since I am here already, I like to notify an upcoming event that we co-organize with the IEA Geothermal and Geothermica, and where also the IEA energy storage will have a role. This is an UTA symposium, which is held on the 28th of February in Offenburg, just before the Geotherm side event, Geotherm event. And you can sign up through the registration link in this slide. Thank you, everyone. And if you have any questions, my colleague, as I told, is joining the panel discussion. And I don't know if I have any time now for questions at the moment, but I'm open for it.
Thank you very much for your presentation, Robin. If we want to be fine with the schedule, we're going to have to skip the questions directly to you. But there will certainly be questions for the Netherlands during the panel discussion. Thankfully, I had prepared a little bit of buffer in the program, so no worries, you will have a very short coffee break now. I will share my screen to show you where we are on the schedule. So it just means that for what is following, we are delaying with 5 minutes. So it should be fine. Let's see if you can see my screen now. Yes. So see you in 5 minutes. This break is a typical Danish break. After 45 minutes to 1 hour, we do a break for the the physical courses, and I think it would be nice for everyone to shake their legs. So please enjoy this 5 minutes break and see you back at 15:10 sharp. And we will be having policymakers presentations, starting with Austria, and then a presentation by the European Commission at 15:15. See you. Yes, welcome back, everyone. And I can see that we have the next presenter ready. So I will ask, I think it's Dr. Sabine Mitter that will be presenting the presentation together with Georg Siebück from Austria. So please, the floor is yours and you can share your screen.
Sabine? Sabine, bist du da? Funktioniert das? I don't know if she's here.
I can see her in the presenter.
Oh,
Yes.
there she is. Great. God. So, Sabine, yeah. Are you here? We can already start.
Yeah, hello.
Hi.
I'm sorry I couldn't follow you in the first part of the workshop. Sabine Mitter, my name, from Ministry of Climate Action. I hope you're having a nice exchange already.
Yes, can you share your presentation?
Yeah. Can you see it? No.
We can see it's not yet in full screen mode.
Yes.
Oh,
Perfect.
okay. Well, it's really, yeah, only quite short. So 3 slides, and Georg and myself will share it. So yeah, my name is Sabine Mitter. I'm from the Ministry of Climate Action and in charge of energy research programs, national level, and also on international programs. And I think you asked about which programs cover the topic of large thermal energy storages in district heating. And I can say we have, of course, generic programs where you can where all different projects can be funded, but we have specific energy research programs with a focus on the energy transition. And yeah, one of them is called easily the Energy Research Program. We have this since, I think, 2010 with yearly call for proposals and with a slightly different focus every year. Depending on the budget, because the budget used to be higher, so up to 35 million euro per year. At the moment, it's this year it's quite small. It's only 10 million euro, but from the beginning of next year, we will come to a similar amount of 30 million euro. So we, in this program, we cover yeah, all different items of energy research. This year, for example, we also have one item on the electricity and heat transition, and there a specific focus also on the thermal heat storages. And it's from the applied research until experimental development. So from the TRL 2 to 7, which is can be funded in this program. And yeah, next year we will have 2 calls per year and covering all aspects of energy research, so all energy technologies, but also storage, conversion technologies, sector coupling, all the system elements, and also hydrogen and fuel cells. And the second, yeah, small program where we cover this kind of projects, where we are today the participation in the IEA projects. We call it the IEA Research Cooperation, and there we also do yearly calls in all the TCPs we are participating, but not every year we cover all TCPs. So last year, for example, we funded, I think, 3 projects in energy storage TCP. This year we start the call expression of interest in January, and as every year in May the application will start for the proposals. And another international or it's transnational partnership is the Clean Energy Transition Partnership, which is also coordinated by Austria. And there are, I think, 7 or 6 topics, or they call it TRIs. And in one of them, we are also participating. It's the TRI 3, Enabling Climate Neutrality with Storage Technologies, Renewable Fuels, and CCU CCS. And there is always in fall, September, starting a call in a 2-step procedure with the full proposals in the next year, I think in March. So that's more or less the R&D programs where energy storage can be funded. And now Georg will tell you about the investment program. So starting from the TRL high 8, I think.
Yeah, thank you very much, Sabine. So my name is Georg Seeberg. I'm from the Austrian Climate and Energy Fund, which is developing the programs, the funding programs on behalf of the ministry. And just yesterday, we started the first program for LTES in Austria, and we have a budget of 15 million euros for the first year. And we really hope that we get a lot of interesting projects. We fund 30% of the investment costs with a maximum amount of 4 million euros per project. So we were awaiting some kind of big projects too. And we have a jury which is evaluating the projects in terms of innovation. There is also be an obligate scientific economy research for 3 years. So we're collecting valuable data to initiate future projects. And so LTS is really a big topic on the agenda of the funding programs in Austria. So Sabine, if you can please switch the slide. I just listed here for you some application examples where you have basically underground storage and district heating are the 2 big topics here. And these are examples, and we try to develop the program as open as possible to all the technologies so everybody can apply for a subsidy. And yeah, as I already said, it just started yesterday. And so we are hoping for very interesting and innovative projects, and then we will adopt or adapt the program for next year. And we have an even bigger budget for next year. So yeah, we hope that we can support LTS on the market. So it will be a good transition for R&D to the market itself. And yeah, that's a very short and brief introduction of the funding program in Austria. And I hope you have an idea. Thanks.
Thank you very much. And I personally think it's very exciting to see that there are specific programs funding LTES initiatives. So I'm very happy to see that. And thank you for your presentation. The next speaker will be Balázs from the European Commission. And he will give a short presentation on the European Commission's point of view about LTES. And after this, we will move on to the panel discussion. But please, Balázs, the floor is yours.
Hi, good afternoon. I don't know whether you can see me or the presentation because it seems my camera is disabled, but I can go to this one now. You should see it, if I'm not mistaken.
Yes, and you're not in full presenter mode, but we can see your screen at least.
Okay, I will try to put in a full presenter mode, maybe like this. You can see it in full mode now.
And no, I think it must have shared a different screen, but I mean your slides are pretty wide, so I think it's fine to just go like this.
Okay, so this should be now.
Yeah.
Okay, so good afternoon. So my name is Balázs Józs. I'm working for the European Commission in Directorate General for Energy, and I'm going to make a short presentation today about energy storage policies and more specifically thermal energy storage, the importance in the EU policy. So first of all, on this very first slide, you can see if the slides were moving, that would be fine, but they are not.
Okay. I guess you just need to select on the left, yeah.
Okay, so because I'm just using the... So first, what happened with on storage policy in the EU energy policies in this year? So in March 2023, so about 9 months ago, we had a proposal on the so-called electricity market design. We had a recommendation on energy storage, and we are looking at the so-called national energy and climate plans, the first versions for which the member states should have submitted by June 2023. So on the first one, electricity market design. So we, in this new proposal, we force a kind of national assessment of flexibility need, and including the flexibility needs, we want to focus on increasing the non-fossil flexibility, and which means, of course, in most cases, demand response and storages. Of course, with this, we need to introduce new support schemes to dedicated non-fossil flexibility, and looking at for system operators an alternative to complementary to grid development, because this is what we see, a kind of instead of developing grids, sometimes developing storage and flexibility solutions can be an alternative. And of course, for this, the way leads by the remuneration, so network tariffs, and of course, a requirement to reward use of flexibility services by also remunerating operational expenditure. On the second initiative, energy storage recommendations, so I will speak a little bit more on this in the next slide. We address the member states on various issues, in particular some regulatory barriers, the consideration of storage as grid planning, as I mentioned, for the EMD as well, and to financing solutions in order to have all kind of market services remunerated, and energy storage, allowing energy storage to best participate in existing and new support scheme. And on the national energy and climate plans, so we have there is, if you look at the so-called governance regulation of the European Union and climate action, this requires reporting on storage and flexibility on the different dimensions, so principally under energy security, market integration and competitiveness, and thermal energy storage, as we analyze the incoming NECPs now. So I think there are more than 20 of them already, 20 of member states already reported the NECPs. There were a couple of them who specifically also mentioned thermal energy storage in the NECPs so far. So the recommendations, if I want to sum up, there are around 10 elements of this energy storage recommendation we adopted in March 2023. There are some regulatory ones, for example, addressing the so-called double role of storages, the consumer producer roles. For this kind of removing barriers is quite important, and the adjustment of network design and charges and tariff schemes. And here we need to address the so-called double taxation of consumption and production of electricity stored or produced by the storage installations. We need to take into account the flexibility need and adjusting related policies and measures. In the case of networks, we need to take into account storages as alternatives. And of course, we need to look at the barriers for demand response and behind-the-meter storage solutions. In the case of financing, we are looking at different instruments providing stability and predictability of the revenues for the investors. And the monetization of services is very important, because nowadays storage installations cannot always participate in all kind of market services. And if we allow them to participate, it will provide more revenues and kind of more bankability for a storage investment project. And of course, we need to look at competitive processes and to rethink the design of capacity mechanisms as well. And there are some some other elements. The remaining three, first one refers to promoting storage and accelerating storage deployment in islands or remote areas, taking into account the kind of low carbon solutions. This could be very important in those regions which are not directly or not sufficiently connected to the grid. Another important issue is in order to steer investments, we need to provide market data, real-time market data, for example, on the renewables curtailment, which is quite relevant for storage, but for existing facilities as well. And finally, there is a recommendation or a sub-element of recommendation on the research and development, research and innovation, which is kind of looking at de-risking financing instruments and promoting long-duration energy storage and other innovative storage solutions. And going more specifically on thermal energy storage, why is it important for the European policies? So this we see as a kind of very important role in energy transition, a kind of essential enabler of decarbonization of the energy system. Looking at the heating and cooling system, they represent about half of the energy consumption in the EU. So if we replace fossil fuels in these systems with renewables, this would lead a kind of substantial decarbonization asset. And of course, we can see here a kind of increasing electrification of heating and cooling systems in the future. And of course, we see a wide variety of thermal energy storage technologies, for example, using sensible latent or thermochemical heat storage technologies, with varying temperature levels and technological maturity. And of course, this thermal storage system can replace high temperature fuels and fossil fuels in particular, whether we are looking at electric input or heat output, or both heat input or heat output solutions. And the importance of a few policy words on this, if we combine these technologies with renewable-based heating and cooling, this will help maximize the capacity of renewable energy sources, covering heating and cooling demand. Of course, higher proportion of these technologies with variable low temperatures will provide a kind of more decarbonization, as I mentioned, that we see different untapped options here. So, for example, geothermal technologies, thermal and other ambient heat technologies. And of course, we need to make kind of possible for the renewable heating system to achieve the same performance levels as fossil fuel heating system. This is a challenge, but of course, a large thermal storage system combined with district heating or other solutions can provide flexibility and balancing services to the electricity grid. And here we're coming back to the flexibility and energy shifting and demand. So shifting can play an important role, use electrical and thermal energy combining, and this will, of course, lead to a kind of system integration. We also published in 2020 a so-called European System Integration Strategy, where the thermal sector, heating and cooling sector, is playing an important role, looking at building space heatings, but water tanks and other solutions as well. And of course, if we complement renewable technologies with heating and cooling in general, all sizes and all storage time scales need to be taken into account. So in our policies, we always want to follow a kind of technology neutral solution. So by policy making, we do not say that this or that technology should be developed. We see that the market should decide on this, in which technology to innovate into, and or which technology to promote and to invest. And I think for my part, this was my presentation. It's a quite short one, but you asked for a short presentation. So if you have some questions, I'm ready to answer to them.
Thank you very much. And since you've mentioned your busy schedule for afterwards, and the fact that you cannot participate to the panel discussion, maybe we can take one question from the panel to Balázs, if there is one, and then we will move on to the panel discussion.
I have a question, Felix from Plan Energy.
Yes.
I could not see excess heat anywhere, but I think storage is for storing excess heat for instance, data centers and industries is quite important also.
Well, I think we also can take into account excess heat, because I think what you mentioned, so it's an increasing importance of data centers, and because they are increasingly consume electricity and the heat. So I think this is a good idea to take into account and take it up in the policies, because it's if we are going to this direction, so increasing electricity consumption, and this installation produce, of course, increasing heat. So I think this is a good idea to look at it a little bit more deeply.
Thank you. Maybe one more question from Wim before we let you go, Balázs.
Yes, Wim van Helden, AE Intec Austria. Will the specific attention for thermal energy storage also go towards also specific programs for funding R&D and demonstration?
Well, I think so. We have a lot of funding opportunity in the Commission policies. So we have different funds. So, for example, Horizon 2020 Europe for or R&I activities, and there are others on the cohesion funds, or maybe the REP programs member states also propose solutions. But as far as I remember and know, what I say that we may looking at different technologies, but we don't say that we are going to finance this and this and that. So maybe for specific programs and specific projects, there are some financing, but it's deep. So I think it's not really linked to different technologies. So we don't say that we are going to finance long thermal energy storage or other technologies. But if there is a good project and there is a decision on that, so irrespective of the nature and the other technological solutions, we say that okay, we can finance this and that solutions of that project. But I think there are no long thermal energy storage specific programs. Just we focus on storages, but there are number of financing, so the number of different EU funds under which storage is eligible for financing.
Okay, thank you.
Thank you very much. I will start sharing my screen again then. Here. And then we move on to the panel discussion. The program has been a bit shortened for the panel discussion, but I don't think it will reduce the quality of the discussion. We have now 15 minutes for this panel discussion. As I introduced earlier, one of the questions we needed to answer is, are LTES a key element of the future energy systems? And I think both the experts, but also the energy agency and the energy agencies and the policymakers have made quite the statement in favor of that statement, I would say, in favor of a positive answer. We are starting the discussion between the experts and the energy agencies, as well as policymakers, but we will go deeper into this right now with the panel discussion. One of the ideas was also to present the challenges and highlight opportunities, but also show best practices from the EU. So we've had great examples of challenges and opportunities in Germany. We've also seen best practices from the Netherlands and from Denmark. We've seen great policies being put out in Austria. But now we will try to answer the question, what do we need to do to make LTES reach their full potential? What are the next steps? The panel members are summed up here. We still have Wim, Pierre, Jens, and Per-Alex on the expert sides. And then from the energy agency, we have Emil from Energistyrelsen representing Denmark. We still have Emina, Robin, and Paul, respectively from Sweden and the Netherlands. And then we still have Sabine and Georg from Austria, from the policymaker side. So I think today that we've already seen that the EU and the members of the EU are very active in large thermal energy storages. There is money available both for research, but also for replication. And here I can refer to the project Treasure that Wim has presented. And also there is funding available for sharing best practices within the EU. We've mentioned HeatStore, which is a Geothermica project, but there has also been, amongst other things, RES-DHC, which is a Horizon 2020 project, and there is now Support DHC, which is a LIFE project to share those best practices within the member states. But we can also say that these works are also being shared internationally, and that's one of the main targets of our task 39 from the IEA. And there's also some efforts being put into enhancing skills. And I know, for example, the Net Zero Industry Act, but there are also academies that are being put forward. So now I would like to leave the floor for the panel members, and I have a first idea for discussion. One of them has already been mentioned by Per-Alex. Waste heat recovery projects currently have funding opportunities, and it's a very good opportunity for combining with thermal energy storage. So improving these kind of projects will also de facto improve the case for large thermal energy storage. I also think that there is a big potential and this has been mentioned by the European Commission just now, by reducing the temperatures on the network to help further develop district heating networks and help improving or increasing the amount of renewable energy on the system. So does anyone have a point of view on that topic specifically, or any other suggestions on what to do to make LTES reach their full potential? The floor is yours. And I hope someone will take the floor, of course.
Yeah, I raised my hand, but
yes, please. I cannot. Yeah, exactly. I cannot see.
Yeah.
So please go ahead.
Yeah, no worries. So I'm Paul Ramsack, working at RVO, Netherlands Enterprise Agency, a colleague of Robin, but also involved in the Geothermica Corporation, let's say, and other international corporations. For instance, the CTP partnerships, Clean Energy Transition Partnership. That is a partnership that was referred to before. In that one, we are also actively engaged, also with some others around the table here, in the TRI on heating and cooling, for instance. And what we see more and more, basically, as a common denominator is that as we move into a more renewable energy system, storage will become more and more key. And that's not only on let's say in terms of electricity or in terms of hydrogen storage, but definitely on the heating side, this is a crucial thing. So we do think it is a key element. We are, I would say, as people that have been working from the energy agencies on more on the thermal side, we were very pleased that heating and cooling is coming much more, I would say, on the agenda. In the past, we have seen many times that it was focused on electricity. That is changing. And as a next step, I think heat storage and maybe in wider sense, energy storage is getting on the topic. And that means that if you talk about these kind of things, one big project was mentioned, the Heat Store project. That was one of the flagship projects under Geothermica. I think what is needed and what is coming is that we realize large-scale demonstration projects and take it from there. So we have like a long-term vision, but we need to do it hands-on and start with that. So I'm very pleased to hear that in many countries these initiatives are ramping up, definitely as well in the Netherlands. But just as a kind of starting remark, maybe take it from here.
Thank you. Anyone else? And please speak up. I cannot see if someone raises their hands. Maybe Yanis can help me figuring it out. Otherwise,
sure. Go ahead, Per-Alex.
Yeah, okay, Per-Alex from Denmark. Well, I think our job is to make this technology reliable, even if it's Peters or it's aquifers or whatever. So that's, you could say that's a one big job. But the other thing is to demonstrate it, because even if we have 6 plants in Denmark running, there are skepticism by some. Can this last 25 years, as you say, and so on? So we need demonstrators so that it can be seen that this really works. And then if we look for the demand, I'm sure there will be a demand, because we will need heat sources for the winter period, and then we will need this flexibility, and the future systems, they will be hybrid systems, and especially for the peak loads, I think the storages can really contribute. Yeah.
Thank you, Per-Alex. I think it's very insightful what you're saying. Anyone next?
Go on, Wim.
Yeah, one key element that I would like to add is that at the moment, and I also see it from the list of participants to this workshop, it's still a small community working on large thermal energy storage, while we need a much broader community that also consists of lawyers, of permitting and standardization people, of decision makers in communities and within companies, but also of engineers in a broader sense, like with construction companies, etc. So there's a large task ahead, I think, of trying to spread the word and trying to involve all those other stakeholders in order to make the process from idea to operation a much faster process and a much more efficient process. So I think that's also one of the key elements to pick up the acceleration that we need.
Great.
Thank you. Amina?
Yes, thank you, Wim, for this last comments, because I would like to add also importance to involve city administration and to have broader consortia, both at national level, but I think even at European level and in European projects, because we see also, for example, from the UT partnership in Positive Energy District Transition Pathway, that this type of project could be of interest, and also both from national level, but even for European collaboration, because often the competence at the city's level and city administration side is really in need to be connected to the experts through this type of technology-oriented projects. That's why I think in general we need to have a much higher focus on transdisciplinary activities and also design of the transdisciplinary project applications for the coming course.
Thank you very much. Is there a last hand
there
raised?
There is also Jens. Yeah.
Yeah.
Yeah, I just wanted to let you know there's a very powerful funding system in Germany funding the transformation and the new build-up of district heating systems in Germany, with a funding quota of 40% of the investment costs, and also the LTES are also included. Actually, right now, most of the district heating companies are in a phase where they have to work on transformation plans, which shows the development of district heating systems, how to evolve into greenhouse gas neutrality in 2045. But on that way, I think they definitely will take a look at LTES, and I hope next year we will have a broader view on these projects that will be included in these transformation plans and will be more in practice than in the science community. So I think that will also give a further step in the development of LTES, especially in Germany. And the funding scheme is right now limited to 800 million euro per year and will last for the next 5 years. At the moment, it stopped due to other different circumstances in Germany. I hope it will be launched again. But so I think it's very powerful, and I think we also see developments in LTES in that direction soon.
Thank you very much, Jens. Impressive number that you're describing, and I think this kind of sums up. I feel like there is one privileged way that is coming up from the panel right now. So that will be our closing statement. But I think more collaboration with other stakeholders, transdisciplinary approach, but also getting very close to the district heating and cooling sector seems crucial to be able to include those solutions within the future energy systems. So I think more of that in the upcoming years and in the upcoming tasks seems to be an important opportunity. And I think it was one of my notes actually. We are facing a huge challenge for implementing very wide district heating networks to cover heat demand and to make them more flexible and more reliable, and also include more renewable energies. So at some point we are going to face a lack of workforce. We are going to face a lack of knowledge as well and experience. So putting all of our efforts together and working hand in hand with the actors that are concerned by these implementations of new district heating or expansion of district heating will be absolutely crucial. Thank you so much for all the panel members, and your work is not done because we have now the Q&A session. And I've seen that some questions have been put in the Q&A box. Please, experts and panel members, have a look in the Q&A box if you can answer some of them directly. There is also some questions in the chat. One of them is directed directly to Pierre, and I can see his hand is raised. So I will give you the floor, maybe to answer that question.
Yes, sorry, I raised my hand just because I wanted to introduce another part of the topic to your previous question. Just to say that those very large thermal energy storage are really infrastructures. There are new infrastructures, and when it comes to infrastructure, it leads to urban planning challenges, long-term vision, long-term planning and urban planning. And also there is a challenge for the administration to set a clear process to permit such a new infrastructure, to describe the proper risk assessment we should realize. And then once this process is clear, then we can go faster because we are not searching for the way to proceed during some time. So I will keep it short. It was another
Thank
part
you.
of the...
That's a direct answer to what Wim is suggesting. So I think it's very relevant. I will ask you directly the question that was asked in the chat. What kind of tools do you use for dynamic simulations? First one, and second one, can you share the discount rate that you use for energy leasing services?
Yes, so the dynamic tool we are using at NewHeat is Dymola, based on Modelica language. But other tools such as Transys can be used, for example, to represent such large systems. The risk is to limit the analysis to the energetic efficiency and not taking into consideration the behavior of the different temperatures into the storage. But I think it's one of your question just afterward. The discount rate. So we are a small company, still not having too much charges. Let's say we are aiming at typical internal rate of return from infrastructure funds. It used to be 5 to 6% project internal rentability. Now, due to the interest rates that are rising up, then the result for rentability is rising up a little bit. But it's this kind of order of magnitude. Of course, as we are a third-party financer, it makes sense only if we have competitive access to investment.
Thank you. And the rest have actually been answered by Per-Alex. So,
okay, yes.
So you're good. Thank you. Now, if I look at the Q&A, I will try to make it fast because there are quite a few questions. But Robin, you were asked if there is a link to the executive summary. So I will let you see if you can share that link before the end.
Yeah, I'm already working on it. So
perfect. Thank you very much. Otherwise, Robin will send it to me and we will share it through Task 39 network. The second question, that it was quite big, but it's been voted up, and I think it's quite interesting. But the general question in discussion, actually, I think the easiest would be to make Ruud a presenter such that he can ask it directly and make it even shorter. Let me see very quickly. He's right here. I'm making him a presenter right now. So please, Ruud, now you have access to microphone, ask your questions, try to make it sharp.
Perfect, thanks. Yeah, following up on the need to lower temperatures in district heating systems when you build a new system for new district areas or new or that you want to implement district heating in cities or towns that don't have it yet. I think many new systems will have very low temperatures or use the 5th generation district heating and cooling principles. And those usually have pretty low temperatures, especially for the transport of the heats, and maybe have local upgrades with heat pumps. And this is a question that's been bothering me, that large thermal energy storage, such as tanks and pits, wondering if what value they could have, as they really require higher temperatures to be valuable and large central heat generation. So I'm just want to open a discussion to see if there's any vision on where we will head to for the built environment and district heating.
Thank you. Paul, you have your raised hand.
Yeah, just a few thoughts and reflections on this. I think, I agree that we will be moving and we should be moving towards lower temperatures. So medium temperature, low temperature heating, district heating networks, we will see more and more. At the same time, we, of course, have a lot of existing district heating grids that operate at higher temperatures that we could lower, but not probably lower to very low temperatures. And then, of course, if you are at a higher temperature, the transport is more efficient. So it's true, you can plug in less, but it's more efficient. And I would say the most relevant point is what kind of renewable sources do you have? If you, for instance, have geothermal heat from the underground, that can be at 90 degrees, for instance, in Netherlands. So then you would use it at this high temperature, and it makes sense. And maybe you go into cascading. Same for solar thermal. If you can generate a higher temperature, you can use it. So in my opinion, I think the future will be a mix of, maybe not the really over 100 degrees temperatures in district heating grids, but somehow the medium temperature, low temperature combination, cascaded, using different sources at different temperature levels, maybe parts of the system that will be really on low temperatures connected to new buildings, then probably connected to existing buildings a little bit higher. And maybe one interesting final remark, we had a big research project in the Netherlands called Warming Up. And there was one basically work package that looked specifically at the heating grids and the future at this. And they also looked at, let's say, the heat demands and the heating systems in the buildings. And it was like under the title, how low can you go? And one of the outcomes there was that actually we could use way lower heating temperatures than we use now. So already with the existing building stock. So I think there's huge potential to really innovate, to improve it, and to make a totally energy efficient system that is renewably based.
And sorry, maybe if I can complete with the storage, sorry, and related to storage, actually the large thermal energy storage technologies we are looking at are working at atmospheric temperature, meaning that they work quite well up to 95 degrees. And for a given volume, the energy stored in the storage will depend on the low temperature, meaning 95 degree maximum, and then the low temperature. The lower the temperature is, the more energy you will implement in a given volume. Just to say that the lower the district heating network is working, the more efficient the storages will be. Maybe it's another way to answer your question.
Thanks for the insights.
Thank you. Paul, you still had a hand up?
No hand up. I was trying to lower my hand, but you had already done it. Thanks for that.
No worries. So thank you. I can see that there was 3 other questions, and we will shoot them quite quickly. One of them was, are LTES seen as seasonal storages, but it can be used as peaks? Jens has perfectly answered that question in the chat. LTES is not only for seasonal storage at all. It's both for seasonal and daily to weekly storage. It can help balance seasonal demands, but seasonal variations, but also much shorter variations. So it should be used as much as possible. The more a large thermal energy storage is used, the easier it is to get a return on your investment, because you make a great use of it. So actually, the more you use it, the more expensive it can be in principle. And then there were 2 questions about the status of PCM, thermal storage systems, and thermochemical storage systems. I will emphasize on the fact that these large thermal energy storages do not include any kind of phase change or thermochemical storage. So we did not focus on this, but I will let Per-Alex answer the question, and then we will be closing in 3 minutes.
The reason why we are not looking at other, you could say, media than we are doing is that it's too expensive. So if we calculate long-term and large storages, and we use, for instance, phase change materials, then it will definitely take away the feasibility, the economical feasibility.
So to complement and a bit counterbalance what Per-Alex has said, totally true that the investment costs are cheaper. But if there is absolutely no other alternative, for example, no space available to do large thermal energy storage, and no technology that is developed in that sense, then it could make sense to look at a bit more expensive thermal energy storage solutions that will be more expensive, but that would still enable thermal energy storage rather than not at all. So there is a balance to find here, and again, our task is focused on large thermal energy storages. I can see that Pierre has a last comment, and that will be the last one.
I will be very short, but just to explain that those technologies can also address higher temperatures, and in case you can use in a very efficient way, meaning do many cycles of charge and discharge, then the overcost of those technologies can be justified by this very good use of the storages. So any application can find the proper solution.
Thank you.
It's really a question of cycles. Yes.
Thank you very much. And that will be our closing statement. I would like to say thank you very much to, first of all, to all the presenters and the members of the panel that have dedicated some time, both to prepare and to participate in today's workshop. It is the closing event of IEA ES Task 39. So thank you very much. I would also like to say thank you to all the Task 39 members for great collaboration during those 3 years and for the support organizing this workshop. Then I would like to thank some external members that also have helped to prepare the workshop. I will just name a few: LDES Council, Long Duration Energy Storage, DHC Plus, but also Trinomics have been helping out. And finally, thanks for all the participants for their question and for showing up in this discussion. I think we need to work together to try to include even more people in this discussion. And I hope that the follow-up task, which is task 45, will come to this. So thank you everyone for today, and have a great evening. Bye-bye.
Thanks, Geoffrey. Thank you.
Bye-bye.
Bye-bye, everyone. Bye-bye.
Yeah, thank you, Geoffrey, for the organization. And